today is on gas law. So during which we are going to relate these three quantities together. The pressure P, volume V, and temperature T. So this is how we are going to relate them together. We relate the two and keep one constant. So that we are going to check how do they relate together. Then the other one will be what? Kept constant. Let's start by relating pressure P and volume V together by using this diagram. If you look at the first diagram, where we have both diagrams have the same number of molecules. But if you look at the first one, the volume is higher than the second one. So and if you look at the pressure inside, the pressure here is lesser than this, which means when you reduce the volume, you are increasing the pressure. So that the pressure and volume, they are inversely related. So let's use mathematical expression to explain them so that pressure vary inversely as what? Volume. Which shows that pressure is equal to K over V, where K is what? Constant. That is the third quantity. Make the K the subject of formula. You are going to have K is equal to PV. And let me tell you, whenever you have something like this in mathematical expression, you can repeat it. You can have P1, V1 is equal to P2, V2. Once this one is standing as what? Constant. And when you relate pressure and volume together, that gives what? That gives Boyle's law. So if you are not asked to state Boyle's law, very simple. You just say the pressure of a fixed mass of gas vary inversely with what? Volume, where temperature remain constant. So under this one we keep our temperature constant. Now let's relate pressure and pressure and temperature together. Now let's use this diagram. So if you look at this diagram, so you see that here where the temperature is low, T1, T2. I said that the T2 is greater than T1. This one, it means that temperature here is less to this T2. So because we have increased temperature here, you can see the pressure between the molecules. So it means that when you increase temperature, the pressure also will increase. When you increase temperature, the pressure between the molecules also will increase. So we can now, that one shows that the pressure and temperature, they are directly related. Now let's express it mathematically. Therefore, we have pressure vary directly with temperature. So we have pressure is equal to KT. Then make K the subject of formula. We are going to have K is equal to P over T. Like I told you before, when you have something like this, you can repeat it. So this one shows that P1, T1 is equal to P2 over T2. And when you have something like this, we call this one, when you relate pressure and temperature together, and that is what? That is Pressure law. Because we have pressure there, we call it Pressure law or Gay-Lussac law. Now let's go to the third one by relating volume and temperature together. Volume and temperature. So we use the same diagram. Look at this one. They have the same number of molecules. So which means we kept number of molecules constant. Then pressure is also what? Constant in this case. Therefore we have, look at the number of molecules here. But because temperature here is low, by the time you increase the temperature, you see that they are going to what? The pressure between them will increase. Likewise, they will occupy more volume. So that the volume here is greater than the volume here. Because the temperature here is greater than temperature here. Which shows that the higher the temperature, the higher the volume. So we can say the temperature and volume, they are directly related, like what we did under Pressure law. Then we now express it mathematically like this: volume vary directly with temperature. Therefore, volume is equal to KT, where K is what? Constant. Then make K the subject of formula. We are going to have K is equal to V over T. And like I said before, when you have something like this, you can repeat this. It will give you V1, T1 is equal to V2 and T2. And this is called Charles law. When you relate volume and temperature together. So when you are asked to state Charles law, just say the volume of a fixed mass of gas vary directly with absolute temperature, where pressure remain constant. That is Charles law. Now, let's go directly to general gas law. From these same three parameters, we have P1, V1, or let's say PV over T is what? Constant. So when you have something like this, and since this one is equal to constant, that is, we can repeat it. It will give us P1, V1 over T1 is equal to P2, V2 over T2. This is the summary. Let me tell you, you can use this one to get other laws, both Charles law, Gay-Lussac law, and Boyle's law. When you have this one, which means you don't need to cram anything. Just have this one in your brain. Then you have PV over T. If I have this one comprises of three different laws. So I will just say, okay, let me combine this and this. And when you have something like this, it's from inverse. And this is only where you can get inverse. PV, when you combine this and this together, that is what? Direct. When you combine this and this together, it's also direct. When you have product, it's from inverse, that is what? Boyle's law. When you now have ratio, it's from direct. It can be either Charles law or Precious law. So I will have this one, combine this and this, P1, V1 is equal to P2, V2. So which means that this one is Boyle's law, because this is only inverse among these. So under this one, temperature remains constant. I will now say the pressure of a fixed mass of gas very directly with what? Very inversely with volume, where temperature remains constant. Then the second one, I can combine this and this, that is P1, T1 is equal to P2, T2. Don't be confused. If you have the other one is also what? Direct. We have V1, T1 is equal to V2, T2. If you look at it, this one is what? Ratio. Is from direct relation. This one too is from direct relation. I will now be okay. How will I now identify out of the three law? I've identified this and this as Boyle's law, remain Charles law, and Precious law. How will I know which one is Precious law, which one is Charles law? It's very simple. What we just do is that the one that contains pressure, this one is Precious law. So automatically this one should be what? Charles law. Under this one, pressure remain constant. Under this one, volume remain constant. That's the summary of the gas law. So the next one will be on calculation.